What's up, y'all? This is Tom, and this is Like a Math Class. In today's video, we're going to talk about limits, mathematical limits, as they pertain to calculus. We're going to do a little bit of a balance between what is happening theoretically and what is happening practically. And that's kind of the interplay that happens throughout calculus at the very base level of everything that we do within calculus. It's kind of what's happening with theory, what's happening with practicality. Let's get to it. Here we've got an image of a polygon inscribed inside a circle. And we'll say that it's got n number of sides. And actually, let's just call it, instead of a polygon, let's call it an n-gon. So we're going to call it an n-gon because as this thing is getting bigger, as this n-gon, we're going to run out of names for the polygon, but as it gets bigger and bigger, what's actually happening to the polygon inside, or the n-gon inside the circle? Well, you could probably imagine as the number of sides, n, gets really, really large, gets infinitely large, it's basically going to become the circle. So we've got three different ways that we can kind of say this as we kind of get closer and closer to what the idea of a limit is. The first thing that we could say is as n gets larger, the n-gon gets closer to being a circle. Okay, well, that's true. Let's be a little bit more technical with how we phrase this in mathematical terms. So then the next thing that we could say is as n approaches infinity, the n-gon approaches the circle. And now finally, the limit of the n-gon as n approaches infinity is the circle. The way that we write this is the limit, that's a lim, of the n-gon as n approaches infinity is the circle. Let's look at how we can phrase this and how we read it here. The limit of the n-gon, as n approaches infinity, is the circle, is the equal sign there. So this is how we kind of phrase, or how we write limits. Down here is how we write limits, and this is how we read or say the limit as we're talking to someone, or as we're explaining something in class. So the limit of the n-gon as n approaches infinity is the circle. Let's look at a numeric example. Let's say we've got this sequence here. Okay, so we're gonna choose different values for n. We're going to let n get bigger and bigger, and it's going to keep on going. So let's look at this sequence. So n over n plus 1. So this is always going to be one bigger than this here. So we've got, when n is 1, we have 1/2, then we have 2/3, then we have 3/4, 4/5, and so on. Maybe we get up to 9/10, and we could keep on going to 99/100. We could keep on going even and say, what happens if we have 999,999? That's going to be over 1 plus that, 1 million. And so now we can think about what is actually happening with this. What is this sequence approaching? And you've probably already figured it out. You're probably going to say, it's approaching 1. Okay, but does it ever get to 1? No, it doesn't get to 1, but as n approaches infinity, so let's say that, or the limit, let's be a little bit more precise, the limit of n over n plus 1 as n approaches infinity is 1. So if we kind of follow along up here, the limit of n over n plus 1 as n approaches infinity is 1. So that's what's happening for this sequence. As this keeps on getting bigger and bigger, it's going to be approaching 1, but it's never actually going to get to 1. Let's look at another one. Here's another big one that you talk about a lot in class. All right, so here we go again. What's our sequence going to be? It's going to be 1/2. It's going to be nope, not 1/2. Yes, no. Let's start that again. It's going to start with 1 over 1, then it's going to be 1/2, then it's going to be 1/3, 1/4, 1/10, keep on going, 1/100th. 1 over 1 million. Right? So as n gets really big, what is this value approaching? Well, it's getting really close to 0, isn't it? So the limit as of 1 over n as n approaches infinity is 0. Now, there's a couple ways we could actually get to 0. So let's take a look at this graphically. Because if you remember what this graph looks like, it actually looks like this thing down here, right? This is our function. This is our function. We can say f of n is equal to 1 over n. There's our function. So now, let's take a look. We just did what happens as n approaches infinity. Now, when we say as n approaches infinity, we're typically meaning positive infinity. So what we see there is that the limit of 1 over n as n approaches infinity is equal to 0. But now, over here on the left side, it's also very similar. As n approaches negative infinity, what's happening? Well, in this case, the limit of 1 over n as n approaches negative infinity is actually equal to 0 as well. But notice that the values are going to be a little different, right? Over here on the left, as we get a really big number, a really big negative number, we're going to have negative 1 over 1 million. And so what that means is we're getting closer to 0, but we're actually coming up from the bottom side. So we say we're coming up from the negative. And so that would mean over here on the right, with the going to positive infinity, we're actually approaching 0 from the positive side. So as you're approaching this value of 0, we can say, it's approaching from the negative direction because it's the negative y direction. And we're approaching from the positive direction, from the positive y. So here we have the limit of 1 over n as n approaches infinity is 0 from the positive. The limit of 1 over n as n approaches negative infinity is 0 from the negative direction. What about these other two? What about right here? And what about right here? What's going to be happening in these two spots? Well, over on the orange one, where are we going? We're actually heading towards n is approaching 0. So down up here, n is approaching 0. And notice both of these, n is approaching 0, but here we could say we're approaching 0 from the positive direction. Over here is positive, so we're heading towards 0 from the positive direction. So we can even be a little bit more specific there. Well, you could probably see this number is getting infinitely larger. So the limit of 1 over n as n approaches 0 from the positive side is going to equal a positive infinity. And in a very similar way, down in the negative, as we're approaching 0 from the negative direction, what's happening is n is approaching 0 from the negative direction. Now we have the limit of 1 over n as n approaches 0 from the negative is equal to a negative infinity. So here we can see we're approaching the same number from different directions, but we're getting different results. So in general, if we just say the limit of 1 over n as n approaches 0, because we are going in two different directions, the right side does not match the left side, we say that this limit does not exist. So for a limit to exist, you need to be approaching the same value from both the left side and from the right side. So if we were looking at this spot right here, maybe we're saying where n is 1. If we're approaching n being 1 from the negative side, well look, as we're approaching there, we're going to be getting a value of 1. And as we're approaching 1 from the positive side, we're also going to be approaching 1. So that way, if we wanted to look at that more specifically, the limit of 1 over n as n approaches 1, well, that will be a value of 1. So that one does have a limit, because right here, where we have a value of 1, 1, as we're approaching 1, as we're approaching the x value of 1 from the positive, we're getting closer to 1. As we're approaching 1 from the negative, we're approaching 1. So that's why we can say that the limit does exist, and that limit is a value of 1. So what have we learned here? Let's summarize. We say, as we're approaching values, we say that n, or the x, or whatever variable you're using, is approaching some value. We're looking at a specific function, and then we're looking to see, are we coming towards the same thing from both directions, or are we going in different ways? If we're going in different directions, then we say the limit doesn't exist. And if we're going towards the same thing, then we say that the limit does exist. So in the next video, we'll start seeing how does this start applying to curves or to slopes of curves. And that's what we'll be talking about in the next video. I'll see you there.